Good evening, fifth graders. Tonight we're going to be working with fractions and decimals, a little more practice. It's kind of a three-part lesson. So here's the second part today, okay? Before we do that, we're going to do a little bit of review here. Write each mixed number as an improper fraction. And right now I want you to find some scratch paper, go ahead and press pause, find some scratch paper within your house, and I want you to try and convert all of these fractions into improper fractions. I'm going to go ahead and show my work. I'm going to go 4 times 1 is 4 plus 3 is 7. So it's 7 over 4. This one here, I'm going to go 8 times 2 is 16. 16 plus 7, okay, would give me 23. 23 over 8. I have 3 times 6 is 18. Plus 1 is 19 over 3. Do you see how I'm keeping the denominator the same? Right here I have 3 times 2. I get 6 plus 1. I have 7 over 2. 4 times 5 is 20. Plus 9 is 29 over 5. Common mistake or a common error I'm noticing in class as I walk around the room in our flipped lessons here is kids you're adding them up. You're going, for example, like 5 plus 4 is 9 plus 9. You're getting like an 18 over 5 here for this answer, which is incorrect, okay? Just make sure you're multiplying first, and then whatever you multiply, then go ahead and add the numerator to it, and then you have it, okay? Here's another problem. Now we're working backwards, right? Now we're changing these improper fractions into mixed numbers. Let's take a look here. I'm going to have to ask, how many times can my denominator, kind of make these a little bigger. Once again, I want you to press pause and try and solve these. You know I'm going to work them out, okay? How many times can 4 go into 28? 4 goes into 28 exactly 7 times. So my answer, kids, is 7. There's nothing left over because 4 times 7 is 28. Let's take a look here. How many times can 6 go into 36? Once again, 6 can go into 36 evenly. So the answer is 6. This one's a little different now. How many times can 12 go into the number 25? 12 goes into the number 25 twice because 2 times 12 is 24. Now then you have to subtract 25 minus 24, you get 1. So the number 1 couldn't get there, and then I have 12. If I were to work backwards, right, 12 times 2 plus 1 would be 25 over 12. That's how I know I'm doing this correctly, okay? I'm just going to cross that off. That's not wrong. Let's just cross it off so we don't get confused here. How many times can 8 go into 46? Well, I know 8 times 6 is 48, which would be too high. So I'm going to have to go 8 times 5, which would be 40. 8 times 5. What's left over? 46 minus 40 would be 6 eighths. 5 and 6 eighths. Next one, how close can 5 get to 18? 5 times 3 is 15. So I have a big 3. What's left over? 3 fifths. Do you see how it's a 3? Because it's 18 minus 15 is 3. All right. Take a look at some other stuff here. Which is greater, 6/10 or 5/8? Well, once again, you're always going to have to find a common denominator here, right? 6 over 10, 5/8. 8 and 10 both go into 80. And change markers here. Going times 10 gives me 50. Times 8 gives me 48. Which one's bigger? The 50, which means 5/8 is larger. Let's do another one here. 3/8 and 1/3. You see I'm stacking my fractions like always. 8 and 3. They both go into 24. So I'm just using the multiplication method of finding common denominators. 8 times 3. 3 times 3 is a 9. 3 times 8. 1 times 8 is an 8. 9 is bigger, so that means 3/8 is larger. Which is greater, 2/3 or 2/5? Now this one we don't have to show our work because they have the same numerator. With the same numerator in mind, you just have to keep in mind of this. You have 2/3 and you have 2/5. If you're ordering some pizza, we've been talking about pizza and pies a lot in class, right? And you have the same size pizza, let's go with. 2 pizzas that are exactly the same size. Well, with this option, the 2/3 option, I'm dividing it into 3 parts. So this big pizza, cutting 3 slices. Okay, they're pretty big slices, right? Well, the other pizza that's the same size, I'm cutting it into 5 pieces. Obviously, each piece is much smaller than cutting into 3 pieces. So which one's greater? We know that the 2/3 is greater because the pizza with the 3 slices, each slice is going to be bigger than the pizza with 5 slices. So if I take 2 slices away from the 3 slice pizza, are you following? And then 2 slices away from the 5 slice pizza, obviously the 2/3 pizza is bigger. Which fraction is equal to 0.87 or 0.875? Okay, 7/8, 5/8. What fraction is equal to 3 continuous? Okay, 1/3. Let's take a look some more. Which fraction is equivalent to 5/100? Here's some examples today. Okay, we're going to be working with decimals today, so let's kind of take a look here. Let's keep going. With some extra practice here, we're going to be doing some prime factorization, okay? So today when you, I'll just kind of reemphasize what we were just going there with fractions and decimals, okay? When you come to class tomorrow, you're going to be using a calculator in class, and we're going to be changing these fractions into decimals. I'm going to be showing you how to be changing a fraction into a decimal using your calculator, okay? So I wanted you to watch this to understand how we are getting to these points. You're also going to have a page tomorrow that works with prime factorization. So we're going to break down 3 numbers for you, and then I'll be done. So I'll keep going here quickly. We break apart 88. What 2 numbers when we multiply equal 88? Well, I know I could divide 88 in half because it's an even number. What's half of 8? 4. What's the other half of 8? 44. 2 times 44 equals 88. 2 is a prime number, so let's break apart the 44. 44 is an even number. 22 times 2 is 44. 22 is an even number. Let's break it apart. We have 11 and 2. Can I break apart 11? The only way I can get to 11 is 1 times 11, which makes 11 a prime number. This is how this answer is written, just so we're not confused tomorrow. Once again, it's 2 times 2 times 2 times 11. Or we can do 2 to the 3rd power times 11. Here's another one. 72. Let's take a look here. How can I get to 72? Well, I know 7 plus 2 equals 9. With our divisibility rules of 9, we know 9 can go into 72. 9 times 8 equals 72. Do you kind of see how I didn't break this apart 2 times a number? Because I don't know exactly what 72 is off the top of my head. Well, I know a 5th grader might struggle a little bit with that, but I do know a 5th grader knows 9 times 8. Next thing, I know 9's not a prime number. I know 8's not a prime number. Let's break them apart. I have 3 times 3. I have 4 times 2. I know 3 is a prime number because just 1 times 3 equals 3. And I know it is a prime number here. 4 is not a prime number because 2 times 2 equals 4. 2 here. So how would I write this answer? I have 2 times 2 times 2 times 3 times 3. How would I write this answer with an exponent? 2 to the 3rd power times 3 to the 2nd power. Last one. We're going to keep this simple here. Going 4 times 4. Going 2 times 2, 2 times 2. Answer is 2 times 2 times 2 times 2. 2 to the 4th power. One thing I do want to show you is this. I've gone over this several times, but I'm going to go over it again here. Do you see how we started with a 4 and a 4 here? Let's say we start with a 8 and a 2. 2's prime, 4 times 2, 2 and 2. Guess what, kids? It's the same answer. 2 times 2 times 2 times 2, 2 to the 4th power. Okay? Hopefully that helped a little bit. I want to do a little review of improper fractions and mixed numbers. I also want to do a little review of prime factorization for tonight's flipped classroom, okay? Tomorrow when you come to class, we're doing with some more practice with fractions. We're also going to be doing some more practice with decimals. Okay. All right. Look forward to seeing you in class tomorrow.